Okay, so let me do another example. So this is another abstract application example. And so let's read and then we'll set it up. It says OSHA safety regulations require that the base of a ladder be placed 1 foot from the wall for every 4 feet of ladder length. Okay? Find the angle that a ladder of any length forms with the ground and the height at which the ladder touches the wall. So let me say that again. It says find the angle that a ladder of any length forms with the ground and the height at which the ladder touches the wall. Okay. So here's the situation. So we have this wall and we have a ladder up against the wall. Okay? And so it forms this right triangle with the floor and where it touches the wall. So up here, down here with the wall, right? So now we know that this is going to be length A and this is length B. Now, and this is length C, right? Let's say. Now, what do they tell us? They tell us OSHA regulation says that the distance from the wall, from the bottom of the ladder to the wall, should be 1 foot for every 4 feet of length. Okay? So that means that if whatever this length is, this length should be 1/4 of this length. Okay? So that would mean that we would have, I don't want to write it down. So that would mean, let's do it over here. That would mean that C, okay, so whatever this length is, A has to equal 1/4 of this length, right? So that would mean 1/4 of this length equals A. Or in other words, if I just multiply everything by 4, that would mean that C equals 4A. And so I can replace C with 4A. Okay, so now that's the situation I have. Now they also want to know, hey, what's the angle? Okay, so here's the question. What's the angle that any ladder, no matter what the length of the ladder is, will form with the ground when you lean the ladder up against the wall where this ratio is satisfied. So where the OSHA regulations are satisfied. So in other words, what does the OSHA regulations translate into when you're talking about the angle of the ladder with the wall, okay, or with the ground when it's leaned up against the wall? What should this angle be? That's the question. Okay, so let's find out. Well, what can we use? Oh, by the way, we also want to find out what B is. What's the height of the, what is the height? Okay, in relation to the, to how far the ladder is from the base of the ladder is from the wall. Or in other words, in terms of A. Okay, so let's do first things first. Let's do the angle. Okay, so let's find the angle. So what we can do is we can say, okay, since we know that these two are related and they're measured in terms of A, let's use that one because then the A's are going to cancel out. So let's use cosine. So cosine theta is equal to A over 4A, which equals 1/4. So now all we have to do is take the inverse cosine of both sides, right? So we get theta equals inverse cosine of 1/4, and of course we could stick that in our calculator And what do we get? We get approximately 75.5 degrees. And again, if you're in group degrees, it'll give it to you, or if you're in radians, you'll have to convert it, but it's 75.5 degrees. Okay, so that's the angle. Okay, so as long as your ladder makes this angle with the floor, then you'll be in compliant with OSHA regulations. That's basically what we're saying. Okay. Now, what about B? Well, how would we do B? Well, we want to find what B is, so let's use the Pythagorean theorem. So we know that in this case, a squared plus b squared is equal to 4a quantity squared. And so now that means that a squared plus b squared is equal to 16a squared. So now I'm going to subtract a squared from both sides. And I get what? I get b squared equals 15a squared. And now when I take the square root of both sides, again, I'm not going to take plus minus because we're talking about lengths of, talking about physical lengths, and we can't have negative lengths in reality. So b is going to equal the square root of 15a squared, which equals the square root of 15 times the square root of a squared. And again, since a is positive, we don't have to worry about the absolute value. And so this is going to be equal to a times the square root of 15. And then of course this is in, well, no, they don't give dimension, or no, yes they do. This is in feet. So this is in feet. So this is B, and again it's related to A. Whatever A is, now what do we know? We know A, whatever A is, okay, or in fact, whatever this length is, right? Whatever the length of the ladder is, we know that it's going to be, we need to have this 4 times A. Or in other words, this length has to be 1/4 the length of the ladder. Okay, that's probably an easier way to deal with it, right? Because the OSHA regulation says, hey, whatever the length of the ladder is, you can measure that. If it's a 24-foot ladder, well, then all you have to do is take 1/4 of that 24-foot ladder, and so that means that, hey, you're going to be what? 1/4 of 26 is what? Well, it's about 6 feet, right? A little more than 6 feet, right? Or excuse me, 24, I'm sorry. If we look at a 24, that's easier. If we look at a 24-foot ladder and we divide by 4, that means this length is going to be 6 feet from the wall. Okay, so that's a typical ladder, 24-foot ladder. So if we have a 24-foot ladder, you're going to be 6 feet from the wall. If you have a 40-foot aluminum ladder, then you're going to be 10 feet from the wall. Okay, and so what this is saying is, how high on the wall is your ladder going to be? Right there. Okay, so you would do, if it's a 24-foot ladder, then A is going to be 6, and this will be 6 times the square root of 15. Okay. If your ladder is a 40-foot ladder, then this is going to be 10, and then this is going to be 10 times the square root of 15 as far as feet. That's it. Have a great day.